Numbers on a number line. We understand where those belong, but how do we write that in different notations? We're going to look at interval notation and set builder notation and transferring these back and forth. So a few examples. If we start with the open interval -3 to 3, we can write this in set builder notation with braces. We're looking at all the numbers between -3 and 3. So we have all the numbers x such that x is between -3 and 3. Smaller numbers on the left, larger numbers on the right. Since this is between them and not including the ends, we're saying this is x is strictly greater than -3 and x is strictly less than +3. You can cover up one side, -3 is less than x, cover up the other side, x is less than 3, or you can combine them as a compound inequality. On a number line, we should be familiar with this. We have -3 and +3. We're not including either one, so they are both open circles, and we complete that number line. I'm not interested in how far apart these are, so long as they are in the correct places, left and right of each other. I'm not going to put -3 on the right and +3 on the left. The next one, 5 to 7. In this, we have a closed interval. We are including the 5, we are including the 7. So we're going to have a bracket around each one of those. A bracket for the 5, a bracket for the 7. Again, smaller number on the left, larger number on the right, and we're done with our interval notation. To transfer that or translate it to set builder, we use a brace, all numbers x, such that 5 is less than or equal to x. And then x is less than or equal to 7. I'm going to close my set with the brace. Sometimes we don't have a clear start and end. We only have one number to go off of, such as this. This is read, the set of all numbers x such that x is less than or equal to 3. And that's the end of our set. Just the numbers that are less than or equal to 3. Well, how do we write that? I need two numbers here. Well, let's start with what we do know. We know that all the numbers are less than 3, so 3 is the larger number. It's going to go on the right. And we're including 3 because it's or equal to, so I'm going to put a bracket there. Let's come back to this and let's look at the number line. The number line, again, we're starting at 3. It's a closed circle because it's or equal to, and we're going off to the left. Where do we stop? Do we put a number here? No, we don't. We just go off into infinity, negative infinity, in fact. And when we use an array like this, or half of an arrow indicating that we're continuing off, we intuitively know that we are not ending, we're not stopping, so we go to negative infinity. So that's what we write. We write negative infinity. Because we can't reach negative infinity, we're not including it, we just use a parenthesis there. Let's look at intersection and union. The intersection and union of two sets expressed in interval notation. Well, oftentimes these are easier to write out on a number line. -2 to 7 can be written -2, open circle, 7, closed circle. Because we're not including the -2, we are including the 7 as indicated by the parenthesis and the bracket. And we're going to write the 1 and the 10. 1 is somewhere in here. 1 is included. 10 is not included. We're going back and forth between there. Now, this is an intersection. That's an and. It needs to be in both of these at the same time. It has to be in this set, and it has to be in this set in order to be in the intersection of the two sets. So we're looking at these numbers that reside in both sets. That's from 1 to 7. and all the numbers in between, anything we can think of between 1 and 7. So how do we write that in interval notation? Closed ends, 1 and 7, so we use the brackets because they're including the 1 and the 7. Let's look at the next one. This is a union. A union is an OR. We're going to employ the same method to look at it visually. We're going from 3 to negative infinity. 3, open circle, to negative infinity. And then 0 to 9 for our second set. 0 is here, we're including 0, we're including 9, and we're between 0 and 9. But we want OR. We don't care which one it's in. As long as it's in one or the other, we're going to have it in the union of our two sets. So we're looking at one or the other, which will include 9 going to negative infinity. Writing this in interval notation, we have negative infinity to 9, and we are including 9 in that.